at it. Synthetic division only works if you're dividing by a linear factor. Has to be linear. Okay. If you're dividing by some sort of quadratic factor, like if you're dividing by x squared minus 3 or x squared minus x plus 1, some sort of quadratic or even a cubic factor, you have to use long division. But if you're dividing by a linear factor, you can use synthetic division, which I absolutely love. Okay, here's how synthetic division works. We're going to start by doing, it kind of looks like an upside down division bar this way. Okay, doing it this way. And we're going to take just the coefficients from this top polynomial, just the coefficients. Are we missing any? We have a cubed, a squared, a single, and a constant. Not missing any. So I'm taking just those coefficients, and I'm going to leave some space in between. 3, 17, 21, negative 11. Okay, and then I'm going to take the bottom little linear factor that we're dividing by. I'm going to start by taking it, setting it equal to 0, and solving it. What would I get if I solved it? Negative 3. Okay, and we're going to take that negative 3 and put it outside here. And we're caught up, following so far? Okay, this first 3 we're always going to bring down. The first number you always bring straight down. Okay, and then we're going to take the outside one and we're going to multiply it by this one that we brought down. Negative 3 times 3 is negative 9. And then this column gets added together. Remember how bad we are with subtraction on the long division? We avoid that when we do synthetic division. We're going to add these together. 17 plus negative 9 is 8. Very good. And then we're going to repeat that process again. We're going to do outside times the one we brought down here. Negative 3 times 8 is negative 24. Okay. And then again, we're going to add those together. 21 plus negative 24 is negative 3. And then repeating that process one last time. Negative 3 times negative 3 would be a positive 9. And then we'll add those two together to get negative 2. So we started with a cubic function. Everybody see that? A third power, third degree function. And we divided by a linear factor. So these numbers down here no longer represent a cubic function. We took out a linear factor, so now these numbers actually represent a quadratic. All of these represent a quadratic. 1 degree smaller. Froze. Okay, well, I'm writing the word quadratic where it says the numbers on the bottom. Reconnect. Okay, quadratic. Okay, so this 8 right here represents the coefficient of a squared term now. So that would be a 3x squared. Sorry, this 3 represents the coefficient of the squared term. This 8 represents the coefficient of the one next to it, which would be just a regular x term plus 8x. This minus 3 would be the constant, and then negative 2 is the remainder. Remainder. Actually, yeah, let's not write remainder. Let's write it the official way. Good job. I believe last time I did. All right, so we're going to put plus, and then we're going to put that negative 2 over, what did we divide by originally? X plus 3. Hey, Akshay. Pretty simple, quick process. Yeah, I love synthetic division. Again, it only works if you have linear factors. That's the downside of it. We're going to be doing a bunch of synthetic division today, and we're going to be doing that so that we can try and fully factor some polynomials. In the last lesson when we were doing all the long division, we're always given some sort of factor to start with. You're always given, hey, this is one of them, let's divide it. Hey, this is one of them, divide it. But on today's lesson, we're not going to be given necessarily one to start with. We'll have to determine our own to start with, and we're going to do that using what's called the rational zeros theorem. Fancy. Okay. So the rational zeros theorem says that if you have some sort of polynomial and all the coefficients are integers, then every rational zero of it, or every like solution to it, something like that, will be in the form P over Q, where P stands for factors of this little constant at the end. So I'm going to say factors of D And Q stands for factors of the leading coefficient, which on this regular looking polynomial would be A. Gotta mark down my tardies. I'll need to wake up earlier. Alright. So on this first one here, we're going to look for what would be all the possible rational zeros. So not just like what are the solutions, but just what are the possible solutions using the rational zeros theorem. So the rational zeros theorem says that any number that could be a solution to this is going to be in the form P over Q, okay, where P stands for factors of this little constant that's at the end, and you don't even have to use the negative. You just have to write 21, factors of 21. And Q stands for factors of the leading coefficient over factors of 2. Okay, so then I usually make a little list. Okay, my first list is just what is factors of 21. Factors of 21, numbers that divide into 21 evenly. 3, 7. What else we got? What else? There's 2 more. 1 and 21. Yeah. Okay. And then the bottom, factors of 2. That's pretty simple. What are my factors of 2? 2 and 1. Okay. Now, along with these, technically also the positives and negatives of these as well would be factors of them. Okay, so anything in this list would be a possible solution, not necessarily an actual solution, but just possible. If it's not in this list, it's not even possible. So what this does is I look at it and I say, okay, so 3 over 2, 3 halves, is a possible solution. 3 over 1 is a possible solution. 7 over 2 is a possible solution. 7 over 1, just 7, is a possible solution. And then we've got 1 over 2, 1 over 1, which is just 1. 21 over 2 and 21 over 1. Anything else, if it's not in this list, it's not even possible, so I wouldn't even try and work with that. So like if I said, is 5 a possible solution? No, why not? Not in this list, yeah. Is -3 a possible solution? Yeah, -3 is in the list. We've got 3 over 1 here. Negative is right here. What about 9? No, why not? Not in the list, right. It's got to be in this list to be even a possibility of being a solution. We're going to find factors today by testing numbers from that list, testing possible zeros from the list until we reach a quadratic. And then once we have a quadratic, we know how to factor a quadratic. We can factor it using easy factoring, split the middle. If you need to solve it, you could even use quadratic formula if it doesn't solve like with easy factoring or split the middle factoring. So this first one says find all of the zeros, aka the solutions of this right here. First thing I usually check on these is I check to see, does it look like I could factor it by grouping? And one way to tell if you could factor something by grouping is when you look at this back little binomial here, does this have any common factors? No. If there's no common factors in that back one, then there's no way this whole thing is going to factor by grouping. Remember, grouping is what we did last class. So if we can't factor it by grouping, then our next thing is to go in and try and find some possible zeros and then use synthetic division to see if those possible zeros work. So I'm going to make a list of just even the ones that are possible zeros. And remember, we do that by doing our P over Q, where P stands for factors of the -12 or factors of just 12. Factors of 12. And Q stands for factors of the leading coefficient, which would be 1. Factors of 1. And it's always going to be positives and negatives of this. Starting with, what are some factors of 12? 3, 6, 4, 1, 12. There's one more. 2, yeah. Bottom one's pretty easy. What are factors of 1? 1. Okay, so when we're checking to see what our zeros are using synthetic division, we don't even want to bother checking a number if it's not in this list. Like, are we going to check 7? No, it's not in this list. Are we going to check 9? No, it's not in this list. Okay, next up is I make myself a little list of what I have tried, what I have tested, so that I don't accidentally repeat the same ones over again. Because oftentimes you have to test so many that you're just like, God, I don't know, what have I tried, what have I haven't tried? Okay. So I'm going to start setting up my synthetic division, just like we did on that first question. We've got our little upside down division bar. Remember, we're only going to choose the coefficients of this. We're only going to write down the coefficients. So we're going to write 1, 6, 5, and negative 12. Okay. And then we need to pick a solution to test. Doesn't matter, it just got to be in this list. We could do a positive or negative. We could do 3, 6, 4, 1, 12, or 2. What do we want to guess? We're just guessing right now. Sounds great. Testing 1. Okay. Now this is not its factor, this is its actual solution, so we can write it out here. So testing 1 here. Okay, so remember how we do the synthetic division. We bring down the first number, okay, and then we're going to multiply these two. 1 times 1 is 1. And then what do we do with this column? Add them, right. 6 plus 1 is 7. And then we're going to repeat that process. 1 times 7 is 7. Okay, and then add these two and we get 12. 1 times 12 is 12, and if I add those I get 0. We got a remainder of 0. Was that number an actual solution then? Yes, it was. Okay. So these numbers now, since we started with a cubic, these numbers now should now represent the coefficients of a quadratic. Okay. So this would be 1x squared plus 7x plus 12. Okay. So remember what the direction says. We want to find factors or find solutions of the list until we reach a quadratic. So we don't have to do any more checking like what we just did. We found one, it worked, hallelujah. We can now just solve this quadratic normal style. So when we solve this quadratic, who remembers how to solve a quadratic? You can do quadratic formula. You can also say, well, does it factor? Does it look like it factors? Yes? No? Does it look like it factors?
Yes.
Yeah, it totally looks like it factors. What type of factoring? Easy factoring, right. So we want to take this little guy, we want to find two numbers that multiply to 12, but those same two numbers need to add to 7. 4 and 3. Now remember, those aren't the solutions, those are just what you're going to write in your little factoring parentheses. X, 4, and 3. And then to solve, you have to actually set it equal to 0. Because remember, after you set it equal to 0, then you need to take each one of those little parentheses and, and say x plus 4 equals 0. X plus 3 equals 0. What would be that first solution? Negative 4. And then negative 3. Okay, so this question just asked us to find the zeros, which are basically the solutions. How many did we find? We found one with synthetic division, and then we have two others here. There should be 3. If this was a cubic function from the start, there it is. If this was a cubic function, you should have 3 solutions. So I'm going to write negative 4 was one of them, negative 3 was another one, and positive 1 was the one we found with synthetic division. If you were asked to write the factors, 2 of the factors were right here. We found them with easy factoring, x plus 4, x plus 3. What would be the factor that would have produced this solution, though? What factor makes a solution of 1? Think about what would it be as its little parenthesis to get an answer of 1? X minus 1. Good job, Manny. X minus 1 is what factor would have made this little solution here. There it is. We found them all. This one was definitely an easy one. All right, looking at this one, Again, you always want to kind of check, does it look like you could factor it by grouping? Okay, when I look at these back two, that's really where I can tell on the back two. Do they have a common factor that if I group them, I could take it out? No. So I'm not even going to bother factoring with grouping. I'm going to jump right on into, let's start by making a list of possible zeros, possible solutions. Possible zeros. Okay, and those possible zeros, remember, they're in the form P over Q, where P stands for factors of that constant that's at the end, factors of 21. Is this the one we started with? Slightly different, slightly different. Okay, factors of 21. And the bottom one stand for factors of what? 2. Factors of the leading coefficient, which is 2. And remember, you can always do positives and negatives of these. So starting with factors of 21, we listed them out earlier. What do we got? Definitely not a 6. 3, 7, 1, and 21. What about factors of 2? 2 and 1. Very good. Small list on the bottom. Okay, and then I'm going to make, I'm going to go ahead and make a test list of ones we've tried. If y'all could do me a favor real quick, I'm going to switch to pencil for this question, okay? Because sometimes if we find a number that doesn't work, guess what we're going to have to do? Erase it. Yeah. Go borrow a pencil if you need. I happen to have one handy over here. Switch to pencil just for a little bit of guess and check. Yeah, or maybe someone in your group has pencil. All right. What number do we want to check? 3. Sounds great. I'm going to set up my synthetic division. Okay. Remember, we're just using the coefficients. We'll have 2, negative 15, 34, and negative 21. And we only have to find one that works because this is a cubic function. If we could just get it down to a quadratic, then we can factor it or solve it normal style. Okay. I'm going to bring down the 2. We're checking 3, so I'm going to write 3 outside. Okay, remember our process. We're going to start by multiplying. 3 times 2 is 6. And if I add, I get negative 9. And then we're going to repeat again. 3 times negative 9 is negative 27. And then if I add those, I get 7. Holy God. 3 times 7 is 21. Did we find one that worked? Hallelujah. We got a remainder of 0. Good guess, Quinn. Thank you for that. That one did work, which means we don't have to do any more synthetic division. We found one that works. Feel free to switch back to your pen if you really would like pen. Me immediately switching. Okay, these now represent the coefficients of what type of polynomial? If we had a cubic, we took out one linear factor. Now it's a quadratic. Yeah. Okay, this quadratic would start with a 2, so it's 2x squared minus 9x plus 7. Okay. And notice on this one, we're just asked to factor, not necessarily find the solutions, but just factor. I know sometimes people just do both, just in case. But if we just need to factor it, we don't need to actually solve it. What type of factoring would this be? It is a split the middle. Yep. Remember, for split the middle, you're not just looking for two numbers that multiply to c, you're looking for two numbers that multiply to a times c, which would be 14. But they need to add to b. Anyone know those numbers off the top of their head? Negative 7 times negative 2. Yeah, perfect. Now, do those go directly into your little parentheses for split the middle? No, those are just what you split your middle term with. Middle term gets split into negative 7x minus 2x plus 7. And then remember, after that, you're going to group and group. We're looking for, what is the little baby GCF of this first group? Just x. And if we divide both by x, then we'll have 2x minus, everyone know, 7. Good job. Little baby GCF of the back group, not a whole lot. Negative 1, nothing else. Yeah, just negative 1. And then if you divide both by negative 1, negative 2x divided by negative 1 would be a positive 2x. 7 divided by negative 1 would be minus 7. We've got matching factors, which means we did it right. So one would be 2x minus 7. What would be the other one? X minus 1. Okay, so this is only 2 of the factors. If this was a cubic, where's my last factor? It's from that 3. What factor would make an answer of 3? X minus 3. All right. The factor that would make this answer would be x minus 3. There they are, all 3 of them. If you were asked to solve, we know the solution to this one. It's 3. What would be the solution to this one? 1. What would be the solution to this one? 3.5 or 7 over 2. Right. You'd still have to set it equal to 0 and solve it. But it only asks for factors, so I'm going to try and behave and just do what it wants. Okay, well, I wrote the word factors. It always takes a second for it to show up over here that there it is. Okay. All right, let's look at the next one. Oh, reconnect. What causes it to do this is the internet turns off for a brief second. Y'all ever notice that where a website just won't load on your computer? It's the same thing here. Internet just turns off. All right, we got to factor this. 48x to the third power plus 4x squared minus 20x plus 3. Again, I always check, does it look like it's factorable by grouping? Do those last 2 have something in common that you could factor out? Then it's not going to factor by grouping. So looking at my possible zeros then. Possible numbers that I should check with synthetic division. That's my P over Q list. P stands for factors of which number? 3, the constant at the end. Okay. Q stands for factors of 48. Ooh. Okay. Let's make a list. All of these could be positive or negative. Factors of 3. Yeah, there's 1 and 3. Pretty simple on that one. Get ready to make a big giant list for 48 though. 12 and 4. What else? 24, 2. 6 and 8.
16 and 3.
Yep, 16 and 3. And then 48 and 1. Do we get them all? So if it's not in this list, we don't want to check it. This list is not a whole lot of whole numbers. What whole numbers we got? 1 and 3. We could also do negative 3 and negative 1. Everything else is a fraction. Get ready to use that pencil. Okay. All right. I'm going to make a list of numbers I've tested. Let's do this. I'm going to set up my synthetic division over here. I'm going to grab just the coefficients of these. It's not missing any terms, so I don't need to write in a 0. But we'll have a 48, a 4, a negative 20, and a 3. And now I'm going to switch to pencil. Actually, I'm going to bring down that 48 first, and now switch to pencil. Oh, I hate pencil. Okay, what do we want to guess? Okay, I'm going to start with 3. Let's see. Wow, first off, right off the bat, 3 times 48. 144. Sounds great. Add those together and you get 148. And then we got to do 3 times 148. Anyone have a feeling it's not going to work? I have a feeling it's not. It's just going to get larger here, then you add, and then you get even larger over here. So put an X next to that 3 in your list so we know not to try 3 again. What should we try now? 1 sounds good. 1 times 48 is 48. And then when you add, you get 52. 1 1 times 52 is 52, and when you add, you get 32. 1 times 32 is 32, and when I add, am I going to get a 0? No. So is it a solution? No, not 1. I know, I was really counting on that 1. Feel free to work faster than the rest of us if you want to start guessing quicker to help us find one. What should we try now? 2's not in the list. Can't use a 2.
1 over 12.
1/12. Okay. All right. S1 wants to try 1/12. Let's do it. Mixing it up. 1/12. A 12th of 48 is? What's a 12th of 48? 4. Yeah. And then when I add, I get 8. And then we'll have a 12th of 8. That's 8 over 12. 8 over 12 is what? 2/3, yeah. It's not looking good now. I'm going to abandon 1/12. It was a great idea, though. Abandoning 1/12 to avoid having to add fractions. All right, checking 1/2. We got some good guesses up front. Again, feel free to work faster than us if you want to try and find it faster. 1/2. Half times 48. 24. And then we'll add and get 28. What's a half of 28? 14. What do we get when we add? Close. -6. Oh, this one's looking good. Half of -6 is -3, and when we add, we get 0. Everyone give Esvin an imaginary pat on the back. Everyone pat Esvin on the back. That was a good guess. That was a good guess. Okay, we found one that works. 1/2 worked. Hallelujah. So if we started with a cubic function and we took out one linear factor, what do we have now? What is this now? Now that's quadratic. Okay, so this 48 would represent the squared term of the quadratic, 48x squared. 48x squared. Come on, brain. Plus 28x minus 6. Now, are we asked to factor this or are we asked to solve it? We're just asked to factor it, right? What do we usually check for when we factor? What do we check for first? A big GCF. Is there one? There is. What is the big GCF?
I think it's
3, 8, 9. No, 3 doesn't go into 28. Yeah, I think it's just 2. They're all even. So I'm going to take that 2 out at the beginning. That'll be 24x squared plus 14x minus 3. Okay. Now we got to do some factoring here, a little split the middle factoring. We need two numbers that multiply to the a times c. What is a times c? Negative 72? No one likes saying the word negative. And they also need to add to 14. Anyone know them? 18 and 4? 18 and negative 4? I know. We just everyone say it. Max is a genius. All hail Max. Let's check. 18 times 4. Oh, did he use the calculator, genius? 4, 5, 6. Yes. Oh my God, that works. 18 and 4. I didn't even know that was. Okay. 18 and negative 4. Max told us. So again, that's just what your middle term splits into. Minus 4x minus 3. Don't lose your big GCF. Just keep bringing it down. Don't lose it. Remember, after you split the middle term, then you're going to group and group. What's the little GCF of this first group? 6x. Okay. Divide both by 6x and we'll have a 4x plus 3. Okay. GCF of the back group, negative just 1, which will turn them again into a 4x plus 3. Okay. I'm going to bring down my big GCF, and then I'll have x minus 1, or excuse me, 6x minus 1. Come on, brain. And 4x plus 3 would be the other factor. And then we're missing one. The one we're missing is this 1/2 right here. The factor that would create that, we're going to work a little magic with it. You're going to see a little bit of magic happen. That factor is x minus 1/2. Okay. But guess what we're going to do with that 2 GCF? What are we going to do? We're going to take that 2 GCF and multiply it into this little guy here. This multiplied here and here would be a 2x minus 1. Would 2x minus 1 still give you an answer of 1/2? Yeah, it would. There they are, all in their beautiful little glory. All right, let's take